Hello everyone, welcome to another exciting TBC Power Hour. I hope you're cozy in your office chairs or at home with coffee or beer, depending on the time of the day. My name is Boris Kopiak. I'm the market manager for Geospatial Office Software, and with me I have Riley Smith, who is the TBC product manager intern, and we are both based here in Colorado.
Yeah. Hello everyone. I'm excited to bring you some demonstration of SX10 today with Boris. First time we presented together.
So today we're going to focus on SX10 and try to demonstrate why we believe this new system is really good for topographic surveys. Kind of going to demonstrate the workflows and go over the benefits and talk about point clouds and terminology, because a lot of stuff that we have been doing in TBC in the last year has been revolving around point clouds in order to support the SX10 system better. So even if you're not an SX10 user, all of the stuff that we are going to be showing today can be applied to any other scanning data that you might be importing into TBC. We're going to try to optimize our time and focus mostly on demonstrating the workflows. And as a heads up, we are running an unreleased version of TBC 380 that's planned to be released in November. So if you see a message of TBC stopped working, just look away. We're going to try to provide a summary and open for questions and answers. So I encourage you to type in any questions that you might have in the chat window, and we will try to address them as we go, and we'll try to leave some time at the end of the session to answer any questions. So just to recap a little bit about on the SX10, I'm hoping all of you had a chance to see some of the release materials and videos on YouTube or social media. We are really excited. This has been a system that we've been working for a long time, and what excites me as a surveyor, and Riley as well, is that the system is really meant for surveyors. It's built by surveyors for surveyors. We have gone through an extensive beta program with users around the world in the last 6 months. They have been providing us with great feedback, and we have been able to incorporate that feedback in both hardware, firmware, field, and the office software to make sure that this system really answers to any surveyor's needs. So I have to point out it is our best total station ever, and it has additional scanning capabilities. So there's a lot of question, is it a total station, is it a scanner? Well, the answer is both. It is really the best total station Trimble has ever produced, and it has the benefit of having the ability to scan. The top applications through the beta program that we have identified for SX10 are topographic / general surveys, roadway and corridor surveys, volumetric surveys, and infrastructure as-built. So today we're going to focus mostly on this top one, the topographic or general surveys. So when we say topographic map, it means different things potentially in different parts of the world. So to clarify that, this is the deliverable that we are going to be producing today. So a topographic site improvement plan with typical map elements like the contour elevations, roads adjacent to buildings itself, vegetations, any boundaries, monuments, utility lines, clearances, and these are typically used for land development, so for new division or architecture or any civil designs. In this case, you're going to be focusing on a small kind of a drive-through that is going to be torn down and it's going to be redeveloped. When we talk about the workflow, I really want to stress out the importance of using the feature coding library. So the thing with the SX10, it's still a total station. All the workflows that you apply today with your M3s, S3s, S7s, S9s, whatever you might be using, still are the same. So one of the beauties of the system is that the workflows don't change for you at all. So there's just a new checkbox to scan in Trimble Access. So you will still go around creating your feature definition library, and then in Trimble Access you would use measure codes to be efficient and measure with codes in the field, and then drag and drop in data into TBC. You would do your QC. We have the ability to use something that we call scan station setup. We're going to talk a little bit more about, where you can do optional registration in the office, classification, extracting CAD elements and creating surfaces, and then finally putting that plan on a sheet view and plotting to PDF, which we will try to demonstrate in this session. Why using SX10 for a survey or topographic map is it really allows you to capture site information quickly. It's excellent for capturing objects that are hard to measure. Like in this example, we have a lot of arches and bridge elements. It allows you to measure efficiently through busy intersections. Like in this example, we captured the entire area of this of the both roads passing next to our site without stepping on the road once. Back in the office, you get that complete scene. You have much more data from which you can model efficiently, and you can create your the land development plans. The value of TBC is that it provides a true integration of survey and scanning. So when we say true integration, it doesn't mean that we just drag and drop point clouds along with the total station data in. It actually, those are linked together. So everything that you're used to doing with total station, like traverse adjustment, network adjustment in TBC, the point clouds move along. If you apply atmospheric corrections, PPMs, or if you apply ground scale factor, the point clouds behave exactly the same as your other DR shots or your other total station observations. The nice thing with the TBC in TBC version 380 is that we've worked a lot on providing additional value when working with those point clouds. So automatic classification, automatic ground extraction, registration tools are things that provide more efficiency and ability to create some new deliverables quickly. And we've been improving our CAD tools over the last 2 years to allow users to create those topographic maps efficiently and focus on automation and drafting. When we talk about the point cloud tools, so there's a lot that we won't be able to cover today, but we've been adding a lot of new navigation tools, so rendering, so you can see data by intensity, by color, by region color. TBC also performs colorization of the SX10 data, as we will demonstrate soon. Concept of regions is really important to understand. So region is essentially a point cloud layer. The reason why we don't put point clouds on layers, or we don't call them layers, is that objects can only belong to one layer. With regions, a point cloud can belong to multiple regions, depending on the purpose of the project. Limit box is a nice tool to kind of only decide what you want to see in the view. And then you have the ability to segment data, so you use a polygon selection tool and decide to keep in or keep the data out of the selection tool. Ground extraction and classification are very interesting. Like you can see here, automatically recognizing ground from vegetation, from the light poles or power poles. And then some of the sampling tools. One of my favorites is the virtual DR. We hope that we can demonstrate more of these as we go along in today's presentation. Just to kind of clarify a little bit on the terminology, we will mention something that's called scan station. And scan station is a new station setup type in Trimble Access. In scan station, you only have the ability to collect scans and images, so scans and panoramas. You don't have the ability to collect additional measurements. Essentially, you can use SX10 as a pure scanner. If you don't want to be diligent about your leveling, if you don't have the ability to take backsides, you're kind of traversing down the road and you have to go under a bridge, or you have to go into a tight corner, you can simply use the instrument in the scan setup mode. And then in TBC, you have something that's called scan registration. A lot of you know what registration is and have dealt with scanners in the past. For those that are new to scanning, scan registration is nothing more but basically stitching point clouds together. It's a least squares adjustment of point clouds essentially. And one of the things with the SX10 is really we try to bring scanning to servers that haven't been scanning before. We try to make the system as easy so you don't have to have a dedicated scanning professionals in your organizations that only do scanning. Now with the SX10, everybody can become a scanning professional really quickly. I can attest to that because I didn't have a lot of scanning knowledge prior to SX10 project, but now I can say I'm comfortable, and maybe my next one is tackling the TX8 or some of the higher speed scanners. And we'll talk about scan refinement, essentially just additional refinement on top of the scan registration. That was for the slides. I'm hoping now we can switch to TBC and demonstrate how some of these things look like. So here's a blank TBC project, and if I go to a folder where my raw data lives, and you can see here you will have your job file at the same level as where your folder is with all of your data. So if you open this folder, you will notice inside there's images, and the RWI is database where the point clouds are stored. One thing that is important is that the top level file name and the folder name have the same name. The folder is just going to have the name files in extension to it. And so the next step is simply drag and drop the JExcel or job file into TBC. And standard, as you see with the S7 or S9 or any other data, you just drag and drop. And so first thing you see, importing. The next thing you see, TBC is now computing the normals. A normal is one of the rendering methods. It allows you to quickly recognize planar surfaces, and it colors those differently. So if you have buildings or garage doors, you can visualize those in a new rendering mode. While this is importing, we have a few questions. So Holly is asking, can you colorize S7 scans with TBC 3.80? Yes, you can actually colorize. So S7, S9, and VX data will be colorized automatically as you import that data in TBC. Shane is asking, does the SX10 support a continuous topo method? I believe it does. So again, everything that works for the typical total station works with the SX10. Shane is also asking, does the SX10 have a tracking EDM mode like the S6? The only difference between the S6 or the S series and the SX10 is it doesn't have the active EDM tracking. So the MT1000 works with the SX10 only in passive mode, not in the active mode. So as you see, the TBC has finished computing the normals, and the next step in a few seconds that's going to show up is going to be colorization process. So we don't colorize scans in the field. Basically, we colorize the scans as they come to the office. Another question related to Holly's questions: can you colorize S7? So you can colorize, and we also now apply ppm scale correction and ground scale factor on the previous or the other total station data instruments. So this colorizing point cloud is going to run now. Maybe in this case we have, I think, 7 SX10 scans in the project, and I think it took us about 4 to 5 minutes to scan. The thing is that you don't have to, if color is not important for your project deliverable, you can stop. You can say stop and colorize later, and you can see the data. And all the colorization, you can see part of my project here is colorized. Part of it is still grayscale because I stopped my colorization. My point clouds are a little bit big. And you can see here the total station observations, measurements that have been done in the field, and part that has been colorized. If you want to colorize later, you can simply open the colorize command and you can colorize scans at any point. And you can see here, green indicates that part of this scan has been colorized already. The other thing is we recommend before you colorize, sometimes it helps if you process panoramas. So blending images and balancing exposure on images makes the colorization a little bit better. So one thing to note is also that there's things that kind of pile up on top of each other here. Those are three stations that we collected in a scan setup mode. We don't necessarily recommend it for topographic surveys. You use scan station setup, but if you decide to do so, this is how they're going to show up. So these are the observations that we have used with the backside mode. So we started here with the station 52, then we moved here to another station, then to station 51, and then we finished here with the station, I think 50, and there was an alleyway here, and in that alley there was a wall, and we collected three scan stations along the alley without taking any backsides to our other data sets. And this is how that data shows up. It shows up in the centroid of your project, just on top of each other. We use this project because we want to demonstrate to you the process of registering and stitching those scans together. So since I didn't colorize, I'm just going to close this project, and I'm going to open a project where actually I have the colorized but unregistered. So to save us 5 minutes of that colorization, you can see here all the data in color. And if you look at your Project Explorer, everything is kind of the same. You can see the JExcel. You can see here the station setups. If they have a scan next to it, you will see a scan. And then you can see this 301, 302, and 303. Those are your stations that haven't been registered. We can even show this in a 3D view just to kind of give you a little bit of sense of, although without having or not completing the registration makes it a little bit more difficult. I don't know about how quickly is the speed of your internet connection, but if you see some lagging, it might be because of that. TBC is actually spinning the point clouds pretty smoothly. And you can see here the drive-through that we are trying to kind of map today, or the site that we are trying to map today. I'm going to close the 3D view and going back to the plan view.
Boris, just a quick question before you move on.
Sure.
Those free stations, or those scan stations that are in the right-hand side of the plan view, is there a reason why they're placed there? Why the specific station or those scans are placed in that certain coordinate?
Originally, before we did any work, they would go on 0, 0, and if you're working in a state plane coordinates, like in this case, you would have data very far from each other. So we thought if we place the unregistered scan stations in the centroid of your project, it's going to help you visualize where those free stations are. So they're still kind of confusing to look at because there's three stations on top of each other. So you can see some of the building outlines kind of overlapping each other at the moment. Did I answer your question, Riley? So if you go to the point cloud tab, and this is where most of the point cloud operations are going to happen, you're going to launch a scan registration command that's going to take the TBC into the kind of a different mode. So this is one of the first examples where we have of taking over TBC's interface by the command. And you can see here the concept of those scan stations or total station data that had the backsides, and those are qualified here as reference stations. And then you can see on the right-hand side window, you can see the scan that happened in the alley. You can see that wall, and you can see here the white blob where the SX10 was positioned. You can see traces of that building or the drive-through that we can see here. So that wall is this wall here. In the bottom, you can see the registration results in two different colors. So you can see the red is the reference, and the green is the moving station. And in this case, I'm moving the station 301. If if I go to the drop-down list for the moving station, I can see all 3 stations that can be moved in this case. Note that you cannot register stations that have a backside observation attached to them. So those behave as a rigid body like survey observations. We do have some flexibility. If you want to separate scans from those what we call regular survey stations, then you can create a scan station from there, and you can create a duplicate point cloud, and that will allow you to move the point cloud belonging to a station setup that had a backside. But if it had a backside, if it was surveyed like an S7 or S6 or VX, in that case, you cannot register that data using the scan registration command. Only scan setups can be registered using moving station. Another thing to note is that you can use this scan registration command to register any other data that you might have. So if you have a scan data coming from other scanners, you can use the TBC scan registration. So what we've done with scan registration is we took the registration from Trimble RealWorks, we took the cloud-to-cloud registration, and we placed it into TBC basically. You can set up some of your residual settings here and see the thresholds of how successful the registration is. So so I haven't done anything basically. I was just kind of navigating around showing you. So I just opened the command, my 301 was already selected, and I just have to click one button called automatically register pair. And this will find the common points between a reference station and a moving station, and it's going to bring these two together by those common points.
So I noticed there's a box below the automatic, or several boxes below the automatically register pair button. What are those? It looks like pick point pairs. What is that for, Boris?
So occasionally, if you don't have a good station overlap, the automatic registration might not work as well. So in that case, the fallback method is picking point pairs. So you can pick as many point pairs as you want between reference station and moving station, and you can refine your registration using manual pairs. Like in this case, you can see here the resulting registration. Typically, you want to focus on an area that has an overlap, like you can see here, green and red data together, and you can inspect how well they overlap. I typically like to pick a cylindrical object or like a light pole here, and I look at that light pole from a top-down view, and although this one was a wooden one, so it's probably not a good example, but you find a rigid body in the project, and you want to see how well your data registered. If you are unhappy how the automatic registration what it produced, you can simply go to picking points, and you can further refine. If I zoom out here, you can see so here TBC will I think we are still at station 1, but if you're happy with this one, you can simply say add to reference, and TBC will automatically advance you to the next scan station in the project. So you can see here 302 is now next one to be registered, so it's further down in the alley. You can see our drive-through is over there, so looking at the same. So it was somewhere here where my mouse is pointing. I don't know, are you able to see that? But you can again see here the resulting and the scan station. So you can kind of iteratively repeat the process. After every pair, you can optimize that individual pair, and there's a concept of overall refinement. So you can move to the overall refinement once you registered everything, and you can say refine overall registration. Since I haven't registered everything, I'm wondering how that's going to work. But
while we're waiting for the refinement process, one of the questions that came in that I think we should answer right now from Robert was, can you utilize the limit box during registration? And I guess the question I have is, what other tools can you use in the registration windows to check maybe your automatic registration to see if it's
Yes,
proper?
in that registration results, the bottom window, you can use the limit box. So as I said, if you want to isolate and focus on one object of interest, like that light pole or power pole or building facade, you can use the limit box to narrow down to that area. So the one time where you actually get to see the report is in the refinements. You have to run the overall refinement to generate the registration report. So that's pretty important. I know a lot of you want to have that report as a proof of registration for traceability purpose. So it's really important if you want to save the report that at this stage you say yes, and this is going to open a scanned refinement report. And in the refinement report, you can see some of the cloud-to-cloud errors. You can see the overlap and the confidence level. So I only had one station adjustment here, so that's the reason why you're seeing it that way. If you want to register to known control points, you can use the georeferencing tab, and you can almost like a target-based registration, except the fact that we don't automatically recognize targets at this point. So we still recommend, if you're a power user or a scanning power user, we have Trimble RealWorks where the workflows are same with the SX10, and you can just drag and drop JExcel into Trimble RealWorks, and you will have much more registration capabilities there. But the registration, again, for the purpose of a topographic project, I'm not anticipating that you will be using a lot of scan station setups, but we just wanted to show it here as one of the opportunities of things you can do. Actually, I prefer to avoid scan station setups, and one of the beauties with the SX10 is that there's no registration at all. You use your backside, foresight workflow, and all of the data is automatically there where it needs to be. So we just showed a more complicated example in this case to demonstrate and explain that concept of registration. With that, I'm going to close this project, and I'm going to open a project so basically just a continuation of this project where we registered all 3 scans.
Before we move on from registration, Boris, maybe let's answer. There's quite a few questions that came in from it, so while we're on this topic, maybe we'll talk about it a little more. One of the questions that came in from Robert was, will TBC autosave during registration in case of crash? It will not autosave, so it's very important, and Boris and I will both stress this, that you save periodically when you're doing registration or any point cloud work for that matter, to ensure that you don't lose that work that you performed.
Yeah, I think we even in the project settings we have added a setting here for autosave. Might be under user options. It's not autosave, but a prompt save project reminder. So you can set up a reminder to save your project every 5 to 10 minutes or how often you want. Another important thing since I'm here in the user options, so again, I went here, and next to the project settings to the right of it, there's a command called user options. That one is important because there's some point cloud settings to know. So some of those scan registration properties. So if you have problems recognizing colors, you can set your reference and moving scan color. So the default colors are red and green. If you don't like that, you can change that. But other more important settings are ability on how many points you want to see in your project. So what we do with TBC and RealWorks, we have a concept that's called dynamic point cloud loading. So basically, we use the RAM memory to load point clouds, and we can use up to half of your physical RAM. So my computer has 32 gigabytes of RAM, so I could amp this number up to 16 gigabytes. That would allow me to see more point clouds in the project. There's no direct correlation, unfortunately, between the number of points and the RAM. It all depends on your system properties. But essentially, you can see the answer is you can see unlimited number of points in TBC as your RAM size moves up. which leads to one of the questions is what are the physical requirements or computer hardware requirements for working with point clouds. So we strongly recommend that you have an external graphics card, even a basic NVIDIA, I think M1000 or something like that would do the trick. So I think I have here a basic NVIDIA with 2 GB graphic card. You don't have to have a super computing or gamers graphic cards. It will work okay. The second important hardware piece is solid state drive. There's a lot of reading and writing when you save and you colorize and things like that, where solid state drive is going to make an impact. And RAM, if you want to see, if you have massive point cloud projects, if you want to see 10 billion points in TBC at a time, it's recommended that you have as much RAM as you can. The processor, I don't think it's critical, so i5 or i7 will be fine. The other important settings here is how many points you want to point cloud points you want to include in the surface creation, how many points you want to include in the spatial sampling and things like that. So pay attention to these user options. And one of the options we have enabled in TBC 370 is that you can now import and export these options, so you can share those with other users as well. So I'm back here with the TBC project where basically those 3 stations, that 301, 302, and 303 have been registered. So if I follow that process, in this case that automatically register pairs worked perfectly. So I just hit 3 times that automatically register pairs, and I did one refinement. And you can see now if I open in the 3D view, you can see the project kind of registered together in color. You can see your total station observations. So maybe I'm going to leave it from here to Riley. So Riley can cover more of the feature extraction.
Hey guys. So what we're going to go into first is now that everything is registered, generally before the registration too, you take care of things like any errors in your total station observations, prism heights, things like that. Now we're going to move into classifying the point clouds. So right now, if you go to the Project Explorer, you can see that we have a singular point cloud region. When we import SX10 data or any scan data into TBC right now, it merges it all into one region on import.
Can you show us how many points there are in the properties?
So when you select that region, you can also right-click and select Properties, and this will bring up any information about that region, what it's classified under for regards to the LAS format, as well as the color and the rendering settings. Here you can see the number of points, so we're looking at close to 30 million points in this point cloud. So one of the cool and really slick new features that we have in TBC is an auto classification tool. So under the point cloud tab, we have this classify regions. So with this command, what we do is we extract four point cloud types, I guess feature types. I think they're based on the LAS classification system. So we have the ground, buildings, poles and signs, and high vegetation. So it's a pretty simple command. You select the region you want to extract from, and then press extract. And depending on the size of your point clouds, how many points you have, this can take anywhere from 1 minute to 5 minutes. So in this case, you can see at the bottom, there's a loading bar here. So while it's doing that, we'll talk a little bit more about this. We also have a extract ground command here up at the top. This uses a similar algorithm as the classify regions command, but in this case, it's only looking at the ground region. So this is good if that's all you're interested in and you don't care about the buildings, poles, signs, and the high vegetation. But in this case, because we have those 4 class types in this project, we want to separate them out. One thing to note too, when you do the classify regions command, it is going to create separate regions for each individual pole and sign, as well as individual buildings that the algorithm finds are separate. So in this case, we have several buildings, several power pole signs, so we're going to have more than just 4 regions created. We'll have a dozen or more. And we can utilize these commands in the regions group here, such as merge regions, to bring those all together. So if I want all my poles and signs in one group, I can select them all and then merge them as well. If any of the regions are classified incorrectly, which is likely to happen in a lot of cases if you don't have dense point clouds, as the more points you have and the higher the density, the better classification results you're going to get. So you can't expect to take a really sparse point cloud from, let's say, an S7 and perform this command on it and get high results.
Yeah, so essentially it would be the same if using the ground extraction would be the same as using the extract classified point cloud regions and just selecting ground.
Yeah, exactly. Which you can do the same, you can do that from this command as well. Or if I just wanted to extract one of these regions as opposed to all 4, you can do that.
Mm-hmm. So I'm not sure why is this taking longer than.
Yeah, it's taking a bit of time. While it's doing this, maybe we'll answer a few more questions that came up. I know there were some more registration questions that came in while we were going over this. So one of the ones from Harry here was, did you label the unregistered scan stations? In this case, it was free 01, 02, and 03. Or does the software recognize and label these as unregistered stations? Once the classification is done, I can show this in the Project Explorer, but there's actually different symbology in the Project Explorer for a scan station as opposed to a conventional survey station. There's different symbols. And with a scan station, there's just a scan associated with it, while with the survey station, there'll be actual setup information, orientation information.
Okay. A question from Sean was, will TBC register the colorized TX5 data? So TBC can register TX5 data, but not colorize. So if you import TX5 in TBC, you might be able to register, but not colorize. Mm-hmm. One thing to note, in TBC, we don't do a global cloud-to-cloud registration, so we do pairwise. So if you are using a high-speed scanner today, it's not going to be as automatic as in RealWorks when you do plane-based registration. Essentially, you adjust, you have a concept of, as we said, reference and moving. So if you have 120, you would kind of click on that, automatically register pairs 119 times. So that might not be feasible for you if you're using a high-speed scanner.
Mm-hmm. Another question that came in is from Harry is, are only flat targets supported at this time in TBC? Right now we don't support any targets per se. It's a georeferencing command. What you're looking at is any features that were picked up in your scans, let's say the corner of the building, the top of a fire hydrant, that you have known coordinates for. You can use that georeferencing command to associate the scan point to your global or grid coordinate.
Yep. There's another question below. Just if you can move your mouse, Michael. Will TBC colorize a regular job file, or does it have to be imported as a JExcel? So TBC will colorize if you drag and drop the job file. It's my habit. I like to work with JExcels, and I strongly recommend all of you that are still using DC files to kind of start using JExcel more. So every time before I leave the field, I will export fixed formats in Trimble Access and always use JExcel. It just gives you a lot of more traceability. If something goes wrong with the job file, it's hard to tell because it's a binary file. So it seems like our classification finished.
So, yeah, the classification finished. And you see that it's colored the regions in specific colors. So the vegetation is in green. I'm just going to bring up the View Filter Manager and turn off the total station observations to clear up our point clouds a bit here.
John is asking how long did it took us to perform these scans with the SX10. So the SX10 takes 12 minutes to create. So these were the coarse panoramas. So just a quick panorama. So 12 minutes for a quick panorama that has, I think, about 7 million scans in a full dome scan. 12 minutes, I think, for the scan and 2.5 minutes for images. So about 15 minutes per station. So it took us about half a day on this site to collect scans, but we also took a lot of total station observations, as Riley's going to show later.
Yeah. So quickly to go over the classification. So you can see in the Project Explorer, it's created 24 different building regions, and this is due to the algorithm picking up several buildings and what it thinks is a building and where it determines to be separate. So you can see the front of this building was picked up, but the top was not. And this is due to the point cloud density once again. So the more density or the higher density you have, the better classification results you get. And you can see there's some trees as well. You can change these colors by just selecting the region, right-clicking, and going to the properties, and changing the color here, the region color. But right now, this is how TBC automatically colors the building vegetation, poles, signs, and ground regions. The ground will be in brown, the building's blue, poles and signs in red, and vegetation in green. If I want to merge these, so let's say I want all my buildings on one layer, or I want to separate this building here, which is actually the structure, the site that that we're looking at for this survey, and we can see that building 12. Well, I want to merge everything else onto a different buildings region, so I can select those. I'll select all the rest of these buildings here.
So you're just holding control down
and
selecting.
Holding control button and clicking on each region, and then I can go up here under the regions group and select merge regions. And what this will do is it'll just combine all of these regions into one region. This is just helps more with the organization. And I can give it a name. I'll just call it buildings, or maybe other buildings. Okay. And you see here, as the regions get merged, they'll slowly disappear from the Project Explorer. And then once they're all gone, there'll be a other buildings region.
And so I notice here, Riley, that it's colored a part of the tree as a building.
Yeah, right here.
Can you show us how to, maybe on another example, how to clean that up?
Yeah. So if I want to work on this building here, maybe I want to draw the outline or determine the height. What I can do is go to the View Filter Manager, and in the Point Cloud Regions tab, I know that this is Building 12 region. I can right-click and select View Only This. This will turn off all the other point cloud regions. And you can see there's still some photo stations here. Those can be turned off in the Photogrammetry tab. I'll just turn off everything in that tab for now. So yeah, as Boris mentioned, there's some trees that were picked up as part of this building. That's just due to the close proximity to the building that was found by the algorithm. So one way to segment out this information from the building so that we can perform some CAD tools on the building outline is using the polygon or rectangle select tools. I like the polygon because you can make a really precise selection with this tool. So what you do is click, hold, and drag, and this will start your line, or your polygon, sorry, and then you can select the point cloud that you want to be removed, or the parts of the point cloud you want to be removed. And then when you get to the end, just double click, and this will select that region. And there's two commands that I like using for the segmentation. Instead of creating new regions and separating in that method, we can use the keep in and keep out commands. So in this case, we're going to use the keep out, because what this will do is it'll remove this part, this selected part of the point cloud region from the viewing, from the plan view or the 3D view, and it will essentially hide that region. So if I select keep out, now it's gone, and I've got a pretty clear building outline, and I can start drawing on this. If you want to get that point cloud information back, you can use the get all points. And what that'll do is it will regenerate and show all the hidden points that you use to keep out or keep in command on.
So typically now when you've cleaned out, you would select that and maybe create a new region.
Yeah, so I could select this and I could go create region right here. And I could call it, let's say, drive-through. Okay, and this will create a new region, and it's colored, it looks like, by in the rendering settings by elevation. And I can change that to whatever I want. Let's say I want to show true color so I can see what was actually colorized in the point cloud. And now the next step is starting to use some of the CAD tools that we have in TBC working with point clouds. So we have the typical line string command that I think most TBC users are used to seeing. And this is great for snapping to point clouds and creating line string objects. So I'm going to select the line string option. You can give it a name if you want. Yes, no, that's up to you. I'm going to auto-close this line string because I want it to be a closed building outline. And I'll select OK.
So did we use the feature coding here?
We did. We did. We can go over that after. First, I'll do this build. I'll show how the building outline can be created. So with the point cloud, you can snap to the point cloud with any of our CAD tools. So in this case, maybe I want to snap to the corner of this building. I could simply select it, and TBC will pick up that corner elevation, and I can move around the building, selecting other corners like this. And lost the view there. There we go. And if you have some corners that maybe aren't level with the ground or are at a higher elevation, you can use some of the snap commands that we have as well. So if you right-click while in the line string command, it brings up snap options. Or COGO options, I guess is a better way to put them. So we have things like bearing, snapping to points, middle segments, things like that. So the bearing command I like using in areas where I don't have a point cloud. Let's say if at the corner here I don't actually have a point cloud here, but I have somewhat of a line bearing along this, I can use the bearing command to actually select a point of reference, a bearing, the other corner, maybe another point of reference, and it will actually snap. Give it an elevation. I'll say it's the same elevation as this, and it will create a point there. So I urge users to utilize those commands not only with point clouds but in other situations as well. For time's sake, I'm not going to show the rest of the creation of the building outline just because we only have so much time to demonstrate these.
So I mean, in this case, you notice that the point cloud, we didn't have dense point cloud at the bottom of this building. So as SX10 is still a total station, I strongly recommend that you collect all the critical points with the pole. Sometimes it's easier to walk over a few meters and just collect the data that you need versus than moving a station setup and scanning, because that was one of the rookie mistakes we did in some of the first projects we did with the SX10. We went out and we scanned everything. So you should still rely on your traditional survey techniques and only scan objects that are hard to reach or where scanning is going to pay off. So there's a lot of thinking involved when you go out with the SX10 and what do you want to scan and what you don't want to scan. So keep that in mind.
So what we'll do next is, as Boris mentioned before, we did measure quite a few total station observations in the field. If I turn on the points in the View Filter Manager, you can see several these points all around the drawing. And we did feature code these, and it's really stressed on the users to pick out certain features that you know will not be able or will not be picked up in the scan, such as maybe manhole covers. If the grass is a little too high, you might miss water valves, things like that. So
we need to drag and drop the FXL file.
Exactly. So we'll drag the FXL file in, and then we'll go to the process feature codes, and here we'll select our JExcel and click process. You can see when we process this, some of the labeling is a little off, but we can change that in the text style. Here, select standard, and we'll just change the height to maybe maybe 1/2 meter. Okay, perfect. So right away, see there were some signs that were coded in the field, as well as trees. Objects like this, they're sometimes easier just to collect with a single point measurement as opposed to scanning, segmentating, and then creating a point back in TBC. So those are things that you have to keep in mind. One thing to look at here is the scan data can be used to check some of your feature-coded line work as well. So you can see there's this line that we have here. I'm going to change the point cloud rendering to true color, and we're going to visually check in a 3D view this line string that was collected at the sidewalk. So you see there's this arc here that shouldn't be here. You can see that it's pretty discernible that there's a fence as well as the sidewalk line runs right here. So one way to do that is right-clicking on this and selecting Edit. This will bring up the Edit Line String command. And in the Edit Line String command, we can actually change the segments of that line string. So if I select the segment, I can see that it's an arc when it should be a straight line. So simply I can just select straight, save, and voila, we've got a fixed line string.
I would say this is one of my favorite things with having scans. It just gives you that traceability, and you can see quickly if you made any mistakes. Very often you forgot to change the prism height, or you code the top of the fence, and you actually wanted to get the elevation on the bottom of the fence. This is where scanning really comes in handy, even just from that traceability in QA.
This line string here, you can see there's some issues in the field here. This curve should have been rounded, and there's some issues with the feature coding. So what you can do, I want this still to follow a curve. I can actually change this to a smooth curve, save, and I'll move to the next segment. Also change this to a smooth curve. And you can see it's starting to make more of a clear shape there of where it should be. And I can change this to smooth curve as well if I'd like. And you notice that these don't connect here. The simple way of connecting a line string is in the properties. You just select the auto close option and select yes, and done. Another thing I want to show in regards to the CAD objects is the offset command. This is great in the case of curves. So if I want to create a flow line, the edge curve, top, back, things like that, and right-click on the line string, select offset line, as well as it's in the CAD tab, not CAD tab, sorry, the offset command, or edit tab, the offset line here. And you can give it a name like any other line string. Select the line you want to offset, so in this case, this one here. You can give it an offset distance, so if I say maybe 0.3 meters. If I want to choose the side to offset, I can select this box and then choose the line or the side I want to offset. I can give it a vertical offset, maybe 0.05, and click apply. And this will create a line string. And then you can continue on if I want to make more and more line strings. This one looks like it was a little off in the distance. And another quick thing while we're looking at that is the measure distance, angle, inverse commands. Those all work on point clouds as well. So if I want to actually check to see how long this curve is, I can select here, here, and it will bring up that distance as well as the vertical distance along the curve. And you can save these like you would any other measurement. As well, we implemented a new command in TBC called the measure point. This works on any object, and what you can do is select, let's say, a point cloud point, any point cloud point, even just this random one here we'll select, and it will bring up the coordinates of that point as well as the region and the scan that it's associated to, and I can save that information. Select save. I can give it a layer, give it a name, and it displays it in the Project Explorer over here under stored measurements. All right.
So one of the quick ways to extract geometry is using the station view, and maybe Riley can show us the virtual DR.
Yeah, so what we can do is find a station. Let's turn on the raw data here and the photogrammetry data, and So we see there's a station here. You can kind of tell by the missing point cloud here with a hole in the ground, because the station isn't able to see in the near vicinity to where it's set up. We can select that station and right-click to open a new station view. And in the station view, what it is it's a perspective from the station. So you'll be able to see essentially from where the SX10 or the S7 was set up, the images, the points, clouds, the total station observations, and any of the points that were taken. And we've implemented a new command, as Boris mentioned, is in the station view is the virtual DR. And this virtual DR command, what it does is it takes overlapping images and uses the station view orientation and the depth from the point cloud to actually calculate points in this view. So you see the orange lines in the station view. These are image frames.
Yeah, one thing to note with the SX10, we have actually 5 cameras on board. So those are all the images that you're seeing and all the frames.
Yeah, so I can turn those off here in the View Filter Manager under Image Frame. And those will move. And you see that the image looks kind of grainy. This isn't actually the image. Those are the point clouds overlaid over top the image. And so if you turn off the point clouds, you'll actually see a clear, definable image. Let's give it a second to turn off. There's so many images in here, it's going to take a second to turn them all off. You can see there, like I mentioned before, there's total station observations and the points they're associated to. So how the virtual DR command works is there's a checkbox here down at the bottom, and this turns the virtual DR on and off. And so if you check this, what it does is now all of the CAD, the measure commands, create point, create line string, things like that, they all will use the virtual DR functionality to create the positions for those objects.
So one of my biggest concerns when we started working with the SX10 is that if you scan in the full dome, that you might not get point exactly on the corner where you need it. So in this case, we leverage the combination of point clouds and images to extract the point exactly where you need to have a point. So all of the commands that extract data like line string, measure points, create CAD points, they use combination of point clouds and images. And it seems like sometimes the station view is not as fast if you have both point clouds and images on.
Yeah.
So if you turn point clouds off or if you turn images off, it behaves much faster.
Yeah. So we'll turn off the point cloud regime. You can see that gets rid of that grainy feel to it as well. So I've got the virtual DR selected. Let's just create a simple point. So if I select create point and select the coordinate. Now let's say I want the corner of this building or even a window. That's a pretty common workflow is selecting windows. Actually use the line string. That would make more sense. So what I can do is select the corner of the window. And you notice it's not a selection tool, it's now a window tool. So if I select here, it brings up a zoomed location of that picked area, and you can actually more precisely define the location you want. So if I want this corner here, I can select that. And looks like we don't have a point cloud point. Let's see here.
We turn them off.
Yeah, I'll turn those back on.
I think one thing that can speed up things in the station view, if we uncheck remove parallax.
Okay.
Because that can slow us down, because TBC is kind of computing that right distance of image from the focal point.
One more second to turn on all those point clouds again. Yeah, it's important to note that we're working with 30 million points here. So, as Boris mentioned before, the more points you have, it's going to affect your TBC's performance. So we'll turn off the remove parallax so we can get this working a little faster.
So maybe in the meantime, as we're running out of time, we can load the finished project.
Desktop. Topographic
TBC project.
Yeah, this one here.
Just double click.
So load that up. Okay, so back in this one now, we've got the station view loading a little quicker. That was a good suggestion by Boris to turn off the remove parallax. We'll select the coordinate back to the window point, select here, and it creates a point there. Oops.
That's opening up.
Opening up the other TBC project. And I'll continue to move around the window, selecting the points. And let's go to this middle rung of the window here.
So even if you don't have point cloud exactly on the corner, so what we do is basically we get horizontal and vertical angle from the image, and we get the distance information from the point clouds. So that allows us to create point very accurately.
Yeah, and once I'm done, I can select the auto close option, and there I've got a window created, or an outline of a window created.
Yeah.
So this kind of goes over most of the CAD tools that we have working with point clouds, and I urge you to use the virtual VR a little more and test it out and see what you think. So now we're going to move on, and we'll just close out this project and look at our finished project. Due to time, we can't show you the whole process, but we'll show you what we were able to create. So I'll go to the plan view. So when we're all finished, said and done, we were able to create a building outline. We were able to do hatching. You can see there's a asphalt hatching as well as concrete. There's labeling. We have the features. We have underground utilities. A lot of information here, as well as the contours. So an important thing that we won't show in this power hour, but definitely in a future power hour we're going to go over, is creating surfaces and contours from SX10 point cloud data.
So that's where the ground extraction is really useful. So you would extract ground, and you would then create your topo map with surfaces and contours. So Riley, how long did it take you to create this in TBC?
To create the project and get it to a finished plotting stage, it took me roughly 8 hours. So one day.
So it took us half a day to collect the data, and basically 1 day to create these deliverables. And this was all done in TBC?
This was all done in TBC, yeah. Everything from start to finish was done in TBC. And you see, just quickly, we'll overlay the point cloud regions and see how everything kind of fits. What we've done, too, is we actually drag and dropped a VCL template into this drawing and created a topo plan sheet view. And you can see that's opened up already over here. And we used a title block. We inserted a legend, which I had as a DWG file, and I inserted it as a CAD block. We have scale bar, all the typical information you would have on a topographic plan, titles, things like that. And then we have a dyna view here of the plot.
So all of those tools are located under drafting ribbon.
Yeah, exactly here. So the dyna view option here, creating, importing blocks, so scale bar, the hatching options, images. I inserted this Trimble logo here using the insert images. Once you're ready, your template's done, and you're ready to plot, you can go to the print command here, and we can go print plan set. And this is where we can select our topo plan custom sheet. So we can select our plan set. I want to plot a single sheet, and I've selected my topo plan. And that's good, and we'll go OK. And it will print the PDF out for us. So this is going over how a typical common day-to-day survey workflow can be done all in TBC without using external software. And now we have a finished project. Obviously, I mean, the legend and the coloring can be changed for the plotting purposes, but I added in yellow.
So if you're not using TBC for the final map creation, we've added a lot of new exporters to TBC, so you can export that cleaned up ground data or classified data straight into. Let me just close Outlook. You can export that data via recap or pod format to Autodesk or Bentley if you're doing your plotting there. So, or after feature coding or cleaning up your line work, you can export both line work and point cloud to CAD for final drawing creation.
Exactly. There's some tools that we just don't have in TBC, but for the workflows that we've gone over, that we mentioned at the start, things like the volumetric surveys, the topographic surveys, infrastructure as-built roading, these are very, very applicable applications for the SX10 data using in TBC, where we can go from start to finish with one software package.
Okay. So let's try to answer a few more questions, Riley. So maybe, Michael, if you can make the questions bigger. So this, what resolution was this project shot with? So this was all full dome scans, as we mentioned.
They were standard.
Mark is asking, these new commands are referring as a part of the scanning module in TBC. So a lot of those region management, navigation, rendering commands are part of TBC Complete. The scan registration, automatic classification, ground extraction. We haven't covered the sampling tools or converting point clouds to CAD points. Some of those tools are part of the scanning module. What is the point cloud density in millimeters? I forgot, Riley, in the full dome. Do you remember what was the resolution at 50 meters?
That I don't know off the top of my head, but we can. I've got some information here. If you go to this link to the SX10 webpage, there's a data sheet on the SX10, and it'll actually give you that information. I think it has, it's either 50 meters or 100 meters that it gives the resolution to, but I think at 50 meters you're looking at around 1 centimeter, 1.5 centimeters, depending on the scan or the type of scan you do from the 4 options that we have. So we have the coarse, the standard, the fine, and the super fine.
So that is all in the spec sheet. So even in Trimble Access, as you select a different scan resolution, you will see that you will see what is the point cloud spacing at a distance. So go to this site and you will see that those specs. So
yeah, I just found some information just to go back and reiterate that. It's at a standard scan setting at 50 meters, you're looking at 25 millimeters resolution. And at a coarse scan setting, it's 50 millimeters.
Mark is asking, what is up with the hill in the middle of YYY Street?
This was actually the top of a car I selected when I was creating the surface, and I didn't take it out in the surface creation. That's why you see the contours going up there. But that can be fixed easy enough.
Yeah. Mel is asking, will virtual DR only work with the CAD module? The virtual DR is part of the scanning module.
Thomas asked, can offset distances be picked in the cloud? Yes, they can. I can actually probably show that really quickly. We have TBC up. If you use the offset command, go to Edit, Offset Line, and you know the distance, or you want to use the distance of a known feature. Let's see, we'll select this line. Distance, you can just select in the point cloud, and it will read that distance in the offset. And you can do the same thing with the vertical as well.
Can the regions be joined so that a group is created yet the original is still available for editing? I think if you, before editing, you create a new region, that will preserve the original, so then you can continue editing and everything is going to be stored in the original region. So just make sure that you create either a duplicate region or you store a region before you start merging and editing.
JT asks, will you be able to unmerge a region? Right now you're not. You can undo a merge region command, but if you merge several regions together, the only way to separate those is segmentating and creating those regions manually again.
Yeah. Bill was asking, how can this data be integrated into design software such as Civil 3D? So we recommend that you export point clouds via recap format from TBC, and then you can import into recap. From there you can send from recap to Civil 3D. And for the geometry, so if you collected points and you feature coded, you would export those with the DWG or DXF.
Mel asks, can you clarify how the feature coding was done? Was it from the measurements or from data with the scan? So it's a combination of both. As you saw, I brought in data, or the data from the SX10 was brought in, and it had point measurements with feature codes. We processed that as well. One thing to note is the CAD objects that we create in TBC can be feature coded. So if I created points, line strings, things like that, I can associate them to layers, and I can associate those points to feature codes and actually process them again. And if it's a tree, it'll bring up that tree symbol and any other information associated with the feature code.
Yeah. So all of the functionality that we showed with the SX10 is applicable to S7. The only difference is S7 doesn't have the scan station setup type. So with the S7, you can also collect scans, and you won't see as many points probably as in SX10, but all of the TBC operations, everything works fine.
Yeah, another question that came up was how would you reclassify an object such as a power pole that was colored green for vegetation? This came from Will. So in that case, it's a little difficult because a power pole can be quite easily interpreted as a tree due to the wires and the height. The simplest way is to select the power pole and add it to a pole region. Or what you can do in the case of like a ground region, if you extract the ground from the point cloud and some of the ground region maybe takes part of a building or part of a tree stump, what you can do is actually take that ground region and extract again from it and run the classification command again just on that segmented region and see if you get better results there.
Yeah, Harry is asking for the network license installations. You have to purchase an equal number of scanning modules as TBC licenses. So if you want to keep it all on the same network license manager, you have to match the number of modules with the number of editions. But we do have the ability to split your licenses. If you have 10 TBC advanced and you only need 3 TBC scanning modules, we can split your network license into 7 that have TBC advanced and 3 that have advanced plus scanning module. Work with our distributor, and our support can help you do that. This webinar is going to be available for viewing, and we will be repeating this session in the afternoon. And for more information, go to TBC site. So TBC 380 is not yet available, but we are hoping to make it available on Trimble.com soon. And there's going to be tutorials on working with the SX10 and the scan information. With that, I want to thank you all for your participation. I apologize for running a little bit over time. We really want to kind of demonstrate as much as we could in this power hour. And if we missed any of your questions, feel free to reach us via email. Again, you can join us in the afternoon session at 4 p.m. Mountain Time, and we can emphasize some of these workflows a little bit better.
Yeah, and feel free at the end of this webinar, when you log out, when you get the feedback form, to put anything else that you feel is relevant there, or if you have any feedback for Boris and I. We appreciate it, and we always want to improve these webinars. And thanks, everyone.
Yeah, thank you, and have fun using TBC and SX10.